I am Dr. J. Shija, SRM IST, Katangulathur, Department of Mathematics, Unit 1, Partial Differential Equation. Problem: find the complete integral or solution of 9 p square z plus q equal to 4. Solution. So this is of the form, the problem is of the form. So f of z is here, p is here, q equal to 0. So for this form, we have to substitute p equal to dz by du, q is equal to a dz by du, u equal to x plus ay. So take this problem as equation number 1. Substitute all this, you take it as star. Substitute star in equation 1. So you'll get it as 9 dz by du the whole square into z, q you replace as a dz by du the whole square is equal to 4. So 9 dz by du the whole square plus a square. So this is the whole square, actually don't take it as d square z by du square is equal to 4. So take dz by du by the whole square as a common term, and so z is here, plus a square is equal to 4 by 9. So we need to calculate dz by du only. So take only dz by du the whole square here and bring all the term to the other side. So 4 by 9, 1 by z plus a square. So we need to find only this term. So we have to take taking a square root on both sides. So you get it as dz by du is equal to 2 by 3 into 1 by root of z plus a square. So cross multiply, we are going to integrate and find out the value for z. So z plus a square dz equal to 2 into d. So we have to get the solution. So integrating on both sides. So you get it as 3, you take it out. So what is the integration of this term? The whole power 3 by 2 divided by 3 by 2 is equal to 2 into u. Constant can be b also, but since it is in the 2, you can take it as 2b. There is no issue in that. So cancel all the terms here. So you get it as z plus a square, the whole power 3 is equal to u plus b. So already you know that what is the value for u? X plus ay. So we can substitute here. So x plus ay plus b. So we have to get our correct solution. So you can take, I think this is 3 by 2, is it? So squaring on both sides, you get it as z plus a square, the whole cube is equal to x plus ay plus b the whole square. So this is the complete solution. Why it is a complete solution? Because we are having the arbitrary constants AB are arbitrary constants, and we are having x and y be the independent variable and z is a dependent variable. So it is a complete solution. We solved the problem. So next problem is problem 2. Find the singular solution of or singular integral or integral of z equal to px plus qy plus under root 1 plus p square plus q square. So what is the solution? Okay, every time we have to look at what type is this. So you take it as equation number 1. So this is of the form z is equal to px plus qy plus f of pq. So you can see here two variables are here, p and q. Okay. So for this, what you have to find first? You have to find the complete integral. So you need an arbitrary constants, and what is the value for p? We are taking as a, q we will take it as b. So substitute this star in 1. Star in equation 1. So what do you get? So z is equal to ax plus by plus under root 1 plus a square plus b square. So take it as equation number 2. So next we are going to, so from here what do you understand? This from here we are having two arbitrary constants, two independent variable and one dependent variable. So we will say complete integral exists. So next we are going to prove singular integral. So that is our question. So that what we have to know? So you have to know this equation. This is equation 2. So we are having a and b that we have to eliminate. Is it so? How to eliminate? So to eliminate a and b. So what we have to do? Differentiate partially with respect to a and equate them to 0. So what do you get? So differentiating which number? Equation 2. Is it? So you have to differentiate this equation 2 only. So what do you get? Dou z by dou a is. So when you differentiate this value, what do you get here? X plus, is it? X plus 1 by root of 1 plus a square plus b square. So this is the whole square root. So it is, you are going to do with respect to a only. So 2a. So cancel the term. So this is equal to 0. So x plus a by root of 1 plus a square plus b square. So from here we can find out what is the value for x is equal to minus a by root of 1 plus a square plus b square. So this one you take it as equation. Already we take it as equation number 2. So here we take it as equation number 3. So similarly, differentiating to partially with respect to b and equate them to 0. So what do you get? Dou z by dou b is equal to, now look at this equation. So you get it as b plus same term. So b plus same value only, but you will get it as b in the numerator into 2b. So cancel it. So I think this is y, is it? Come on, check it out all of you. This is y. We have differentiate with respect to b. So y plus. Okay. So 0 is equal to y plus b by root of 1 plus a square plus b square. So from here y equal to minus b by root of 1 plus a square plus b square. Take it as equation number, already we take it as equation number 3. So this we take it as equation number 4. So our motivation is we have to eliminate, once again we are getting squaring value. So we have to eliminate this. So what we have to do is, you look at this equation 3 and 4. So we are getting through two equation. So squaring and adding. Squaring and adding equation 3 and 4. So what do you get? X square is equal to a square by 1 plus a square plus b square. Similarly, if you square this term, what do you get? Y square is equal to b square by 1 plus a square plus b square. So now you, now if you look at this equation 4, you are having here as y equal to something. The value we have calculated, so square it. So y square equal to b square by root, square means you get it as 1 plus a square plus b square. Similarly, if you take this equation, you will square, if you square the term, you will get it as x square is equal to a square by 1 plus a square plus b square. So this is what we are doing now, squaring and adding third equation and fourth equation. So now we have to add the equation. X square plus y square is equal to a square by 1 plus a square plus b square plus b square by 1 plus a square plus b square. So we are having the common LCM 1 plus a square plus b square. So a square plus b square. So now you have to subtract the term because the term will be involving a square and b square. So we need only a square plus b square. So a square plus b square, the whole divided by 1 plus a square plus b square. So now you take an LCM here. So the LCM will be, the common LCM is 1 plus a square plus b square minus a square minus b square divided by 1 plus a square plus b square. So cancel the term. So what do you get here? So 1 minus x square minus y square is equal to 1 by 1 plus a square plus b square. So we got the term, but what we have to do is we are going to find the square root only. So when you take the square root, you will get it as under root 1 plus a square plus b square. So from here, what do you get? Square root of 1 plus a square plus b square is equal to what? 1 by, just replace the term. So this we will take it as equation number, already we named the equation as 4, is it? So we will take it as equation number 5. So all this we are going to substitute in this equation. Okay, z equal to. So all this we are going to substitute in this equation number 2. So next one is substituting 3, 4, then yeah, one more we have taken as a 3, 4, then fifth equation, is it? So what do you get? So substituting all the value here, so you get z equal to minus x square divided by 1 plus x square plus y square minus y square by 1. So what are you getting here? Other term. Yeah, 1 minute. This is nothing but negative value. That is what we found, is it? So 1 minus x square minus y square, 1 minus x square minus y square, which is square root, because all the values are in square root, minus 1 by root of 1 minus x square minus y square. So take a common LCM as under root 1 minus x square minus y square. So put it in order. So 1 minus x square minus y square. So now we can replace this as 1 minus x square minus y square into root of 1 minus x square minus y square, the whole divided by under root of 1 minus x square minus y square. So cancel the term. Already you are getting z here. So you'll get it as z is equal to under root 1 minus x square minus y square. So squaring on both sides, what do you get? Z square is equal to 1 minus x square minus y square. Come on, take it in the other, take it all to the one side. So x square plus y square plus z square equal to 1, which is a singular solution. So this is the singular integral. If we want to find general integral, suppose the problem is asked for find general integral. So what you have to do is put b equal to f of a. So where you have to substitute b equal to f of a? In this equation. You have to substitute in this. Okay, substitute in this equation. You will get it as. So which equation is this equation? Ax plus by is f of a into y plus root of 1 plus a square plus f of a the whole square. So from here we come to know that we can differentiate partially with respect to A and equate them to 0, we get the, and eliminating A, we get the general solution. So, thus the problem is solved. Thank you.